Hello and welcome to the second part of the Z Shell line editor or ZLE tutorial. This time we'll go a little deeper and the topics will be a bit more complicated, but if you stick around I promise you'll learn a lot. We'll first start working with file descriptors and how they're created, then get into handling them with the ZLE capital F flag for asynchronous code execution. We'll show how this can be used to handle arbitrary data over the network, including a little demo for a type of shared terminal session between users. We'll also break the ZLE capital M flag by showing that it's actually possible to print arbitrarily many rows of data with it. So, a file descriptor or FD is a process-unique identifier for a file, pipe, or any other input-output capable object in your system. You're definitely aware of three of them: the standard in, the standard out, and the standard error, which are assigned to the numbers 0, 1, and 2. Well, it turns out you can make your own with the numbers 3 through 9, and since they're process unique, as long as you're in different processes, you can make all 7 of them over and over. First, we'll need a file, but for our purposes, a named pipe works better, and we can make that with the make first in first out command, and I'll just name it pipe. To make it two-way FD with the label 3, we'll just say execute 3 left right pipe. No spaces. Now, if we echo information into the FD, we can cat the pipe, and there it is. To do this backward, we'll just echo hello there into the pipe, and if we read into the variable line from that, we can echo the line, and there we go. Now note that these FDs are actually stored in a given folder and you can cat them. You can get the process ID of your current terminal by echoing the double dollar symbol, so it's 10,320, and the FDs are stored in the directory processes double dollar and FD, and you can see it right there. 3 points to home, 5 code scripts, Z lesson 2 pipe. Ta-da! So if you want to, you can say this is a sample into pipe, and then you can cat the processes double dollar, FD, and 3. And there we go. It's essentially the same thing, but we tend to use the ampersand syntax. You can also make a pair of one-way FDs. So let's make another pipe. Let's call it pipe 2, and we'll make an execute 4 into pipe 2, and it'll wait until I make another one, execute 4 out of pipe 2, right? Now if we echo some info into the FD, it can be read on this side into the line variable again from 4, and if we echo line, that's it. Now you might be wondering why exactly I'm talking about FDs. Well, it turns out that one of the most powerful features of ZLE, which uses the capital F flag, requires them explicitly. So let's get to that. So, ZLE capital F takes an FD and a handler function and installs it for that FD. If the handler argument isn't given, any existing handlers are removed. So, let's make the pipes. And the FD. And now let's make the handler. First, we have to clear the existing output to ZLE with the capital I flag every time. Then we do this clever trick, which is if not read R line and from the given FD, then we destroy the handler. Otherwise, we just update incoming data line. Oops. Now that top line means that it's going to read into line, and if that line is empty, then it's going to destroy the handler. And that's that. Now we install it with capital F3, which is our FD name, and handler. Oops. If we echo information, let's say it's around 9 a.m. into the pipe, it'll show down there. Now the possibilities with this are endless, because let's say this is a very basic example. Now when I run this, every 5 seconds I will get the time on this terminal, and I can keep typing, and it'll just be there. I could have this be network data, I could have this be scraped data, it could be pretty much anything, and notably this handler could also be running ZLE widgets and all kinds of things, so So let's do a much more interesting example. I'm going to be doing a network example over a remote connection to a laptop on the other side of my apartment. I'm going to be SSHing into it twice because I'm going to be using netcat on these two, and I'm going to be using a built-in Z-Shell TCP module on this side, which you can load with zmodload Z-Shell net TCP. First, let's listen to a connection on 8004. It doesn't matter what port you use, I just chose that one. We're going to save into listenfd the response. We're going to accept a connection into that listenfd. Then make a FIFO pipe, execute 3, like that. Then we're going to netcat into the current computer that I'm on at port 8004. And we're going to pipe into the standard input the output of that FD. And again, save into FD the reply. Now we can create a handler. It's going to be largely the same. ZLE I to clear the output. If not read R line, and the R flag makes it so it doesn't interpret escape characters, then ZLE purge the handler. And finally, ZLE M 192.168.1.3 line. And that's that. Now we just declare it as a handler for FD. And check this out. But you get the point, right? You could be getting pretty much any data here, and you don't have to worry about it at all. Notably, consider that I made handler do something slightly different. Let's just quickly implement this. Now, instead of printing out information, let's just result equals evaluate line. Now, this is quite dangerous, don't do it, but now what happens if I print into it? Well, it's an empty directory, so let's lsla it. See? I can even go W. See? I've made a sort of like a forward shell. Now we're going to have 2 simultaneous handlers and 4 FDs because we want the information to go in a circle rather than back and forth, because otherwise if we send information here and it wants to send it back through the same FD, it's going to just come back to itself. So we're going to make a FIFO left and make a FIFO right. And we're going to make an FD3 that goes into the right, and over here it's going to come out of the right. We're going to make another one 4 that comes into the left, in from the left, and here 4 that goes into the left. This way we have a whole circle. Now, the left side is just going to print out information that comes back from here. So we're going to make a handler, clear the output. If not read, we purge the handler, and we return 1, honestly should do that, and echo line. And we install that on the incoming FD, which is 4. On this side, we're going to run commands that are sent from here, and we're going to send the output of those back here. So let's make that handler. Then we're going to save into result the evaluation of line. We're going to print line first and then print result. And this is where things get a little bit tricky. If we just echo the entire result into the FD and send it over, it's going to come in 1 line at a time. So it's going to echo 1 line, give me a new prompt, echo a new line, give me a new prompt, and so on. If we want it to display properly, we need to somehow make it into a single string. And we can do it this way. We echo the result, pipe it into sed, which will insert into each line a new line globally. And then we pipe that into translate, and we remove all the actual new lines, and we pipe that into the thing that goes out, which is 4. And that'll be that. Then we install that on the incoming data, which is 3. Oh, I actually forgot something. If you send the string like that, it will hang because it won't get an EOF or end of file. We have to add it manually, so let me do that real quick. That'll actually terminate it properly. Now, if we do it from here, we'll say echo W into write. See? And that's it. Technically, we have a shared terminal session. Of course, we can't see what this person is doing, but if I were a person that's helping the person on the right do stuff, this is pretty nice. It's also just a showcase of the power of this tool. You can make pretty arbitrary things happen. But I thought this might be an interesting example to learn how to deal with multiple FDs and multiple handlers simultaneously. And you can of course do a lot more. Now you remember the M flag for ZLE? Able to display one string? Well, check this out. It's gonna go away if I type enough. But the point is, I'm gonna write some absurdly long command. It's gonna have 10 million pipes and symbols, and I just press that and it's there. Now, you probably don't want to print the entire LSLA underneath your command prompt, but the point is you can do this. How? Well, let me show you. First, in my ZSH RC, I have this, which gives you your TTY number. I'm on PTS2. You can't get it from inside a ZLE widget, because the ZLE widget runs sort of headless. Then you get the STTY size from these and so forth, and some Python us here. Basically, we import OS and system. System for the system arguments, which is this TTY size. So we run the LSL command and split it by new lines into strings. We then cut out all the empty ones and take an output string to be empty. Then we simply pad every single string with as many spaces at the end as it takes to roll over to the next line. Essentially, this is all just one string with a lot of spaces at the end of it. Huh? Now, I wouldn't use it for this specific purpose, but you could, for example, follow an IRC chat on this and keep, updating it every 10 seconds or whatever. You could display literally any information that you like. You'll just need a little bit of scripting for it. Anyway, I hope that this was somehow able to convince you that this might be an interesting thing to look into. Anyway, I'll see you around.